Hi learners, welcome back to CS 3244 Machine Learning. It's week 2 now, and we're going to introduce our first algorithm for actually doing learning. It's called concept learning, and a little bit surprisingly, it turns out to be completely impractical, but it's very useful to introduce the key concepts, no pun intended, of machine learning and the problem with bias-free learning. So let's get started, shall we?
Hi everyone, welcome back to Machine Learning Week 2. Today we're going to cover concept learning, which is an oldie but goodie. It is a useful tool to analyze how we're going to talk about certain concepts of machine learning. You can actually use the textbook that's on reserve in the library. This is Tom Mitchell's textbook called Machine Learning that has the second chapter on concept learning, which is really helpful to review the materials that we're going to cover today. So every week we're going to do a recap of what we did the previous week and also go over the forecast for what we're going to cover this week. So last week we talked about the important aspects of learning, right? We said that learning has 3 components which we need to have and pay attention to. That a pattern exists, that oftentimes we might not be able to formally write down a formulation for it, that's why we want to learn it, and that we have data for it. And the third point is the most important because without data, you wouldn't be able to learn from it. So even if there's no pattern or even if it's amenable to being written down mathematically, we can still run machine learning algorithms on that type of data, but we have to have data. Okay, and for the bulk of the course, we're going to be focusing on supervised learning. So that's where we have an unknown target function, which is represented by f, taking some input that could be a vector, and it's going to generate some type of output y, okay, which could be discrete or continuous. And we're going to learn this target function approximated using some data set. And this data set is going to consist of a number of instances, each row being part of the data set having, say, a row by row layout. We're going to call this entire data set D, which is basically comprising of all the x's and y's. So we'll have a capital X for the matrix of x and a column vector y. Okay, and the learning algorithm that we're going to execute might be parameterized by some parameters. We're going to call those theta, or in other cases, you'll see W's, and it's going to pick a hypothesis from a target set of hypotheses that has available to choose from of script H, which might be infinite in size. Okay, but let's take a look at the learning outcomes for this week. So today we're going to talk about concept learning, the idea of learning a concept from examples, all right? We're going to see that when we're talking about discrete spaces, that we can order concepts from general to specific so that we can understand what hypothesis could be more specific. Okay, cover more positive examples or less positive examples. Okay, so then we're going to go over version spaces. Version spaces are going to allow us to think about multiple hypotheses being valid within a certain context of a data set. And then we're going to go over in the post-lecture the candidate elimination algorithm, which is going to be a more sophisticated algorithm than the initial algorithm, which we're going to look at, which is called find S. We're going to conclude by thinking about the need for picking new examples in an active manner, and also talk about the important concept that we'll need inductive bias in order to achieve a feasible learning outcome. This one we're going to cover a little bit also in the pre-lecture. Okay, so let's go on to the material.